Welcome to Statics Lectures by Civil Thinking, and today we are going to solve a problem on resultant of force system. Now before I move on, I suggest to you to please watch the video lectures in sequence one by one so that you will understand better. The playlist link is in the description or also click on the pop-up on your screen. Now coming to the problem, a beam is subjected to a loading as shown in figure below. The resultant force on it and its distance from point A is. Now this is the figure. As you can see, this is a beam, right? There are point loads acting. At A is 100 upwards, at C is 200 downwards, at D is 400 upwards, and at F is 50. Okay, it is downwards. Now we have to find the resultant of these all these point loads, and we also have to find the distance of the resultant from point A. Okay, now let us first find the resultant. Now all of these forces are in the vertical direction, right? So let us assume the upward forces are positive and the downward forces are negative. Okay, now let R be the resultant. Then resultant is summation of all the forces in the vertical direction. Let the vertical direction be Y. Okay, so resultant is summation of all the forces in Y direction. Now 100 is upwards, right? So it is positive because upward forces are positive, and 400 is also upwards, so it is 100 plus 400, right? Now 250, they are both downwards, so they are negative, minus 200 minus 50, right? Now 400 plus 100, it is 500, minus 200 minus 50 is minus 250, so it is minus 250, right? And it is 500 minus 250 is 250, right? We get a positive value of 250, right? Because 250 is a positive value. What does that mean? Since the upward forces are positive and we get a positive value, it means the resultant is 250 and it is upwards, right? Because it is positive value and positive means upwards, right? So we get the resultant of 250 upwards, right? So we get the magnitude of the resultant. Now we have to find its distance from point A. We have to find the location of the resultant from point A. Now resultant can be anywhere on this beam, right? So let's assume the resultant is here, which is 250, right? And it is upwards. We have to find the distance of this resultant from point A. Okay, now we don't know yet. Let us assume the distance of the resultant from point A, it is x. Okay, it is x. Okay, now we will apply the Varignon's theorem to find the location of resultant. Okay, now we will apply what? We will apply Varignon's theorem. Varignon's theorem. Now Varignon's theorem is quite easy. I have already made a video lecture on Varignon's theorem. If you have not watched that video lecture, please watch that video lecture. Okay, and maybe you don't need to watch that lecture because I will explain it here as it's very easy. Now according to Varignon's theorem, moment of resultant about a point is equal to moment of forces in the force system, moment of forces about that point, Now what is it saying? Now this is the resultant. Now according to Varignon's theorem, moment of this resultant. Okay, let us find the moment about point A, because we have to find this x distance. So when we take the moment of resultant about A, we might get the value of x. Okay, so according to Varignon's theorem, moment of this resultant about point A is equal to moment of all these forces about this point, A point. Okay, the point has to be same. Now moment of resultant about A point is moment of forces about A point. Okay, so let's apply. Now let us assume the clockwise moments, they are positive, and anti-clockwise moments, they are negative. Okay, now let me change the color first. Now let us apply Varignon's theorem. Now resultant is going to exert an anti-clockwise moment okay, at point A. So it is negative. So negative, or how far is resultant normally from A? It is x, right? R multiplied by x is equal to, now moment of the forces. Now let's begin from 100 Newton. Now 100 is passing through A, so the moment of 100 about point A is 0. Since it is 0, so I will not write this. Now let's find the moment of 200 about point A. Now 200 is going to exert a clockwise movement at A, so it is positive. It is 200 multiplied by how far is 200 normally from A, right? Now from here to here is 3 and from here to here is 2, so 200 is at a distance of 3 plus 2 from A, right? 3 plus 2 is 5. 5. Now let's find the moment of 400. Now 400 is going to exert anti-clockwise moment, so it's negative 400 times normal distance. How far is 400 normally from A? It is 3 plus 3 is 6 plus 2 is 8. Okay. Now let's find the moment of 50 about point A. Okay. Now 50, it is going to exert clockwise moment, so it is positive, plus 50 times how far is 50 normally from A? It is 1 plus 4 is 5, 5 plus 3 is 8, 8 plus 3 is 11, 11 plus 2 is 13. Okay, so 50 is 13 meters far from point A. That's why I write 13 here. Okay, so this is Varignon's theorem. Right, now let me use a calculator. So we will get negative Rx is equal to, let me use a calculator, 200 multiplied by 5 minus 400 multiplied by 8 plus 50 multiplied by 13. Now it is negative 1550. Okay, now resultant is what? It is 250. So I'll write 250 here. 250. Let me change the color. Now negative and negative will cancel out each other. This 0 and this 0 will cancel out each other, right? So we are left with 25x is equal to 155. From here we will get the value of x is equal to 155 divided by 25, right? Let me use a calculator. 155 divided by 25. It is 6.2. 6.2, of course, meters, right? So we get the value of x 6.2 meters, right? 6.2 meter. Now which option is correct? Now 250 upwards. So this is 250 upwards and 250 upwards. It means B or D can be correct. Now it is at a distance of 6.2 meters towards right, right? From A, this resultant is towards right of A. So towards right, towards left. So this option is correct, right? Option B. Okay. So this is how we solve this problem. Now if you have any doubts, please comment and see you in the next class. Thank you.